So we're here now at my friend's Dave's place, and he basically makes these domes. What are they called?
This is a geodesic dome, Dave.
Geodesic dome, yeah.
That's correct.
Two Daves, you know. And he's just actually made a video, a very good video, and I want to put it on my site because he wanted to kind of really explain how to make them from scratch to finish. And what did you really find like when you first started making them a few years back?
Yeah.
You found that on YouTube and things?
Yeah, well, I mean, the biggest trick I found was trying to find a complete set of instructions. There's a lot of good instructions out there on how to do individual stages, but in order to kind of one source to find a way to make it from taking the steel in the 6 meter lengths to turning it into a rounded dome, you know, there's a lot of separate sites with separate agendas leading for different things. So this is an attempt, or my video is an attempt to show people how to take raw metal, cut it with simple tools, join it together, and make a lovely structure. You know,
how to do it from scratch, really.
Yeah. So that's the purpose of the video, at least. Anyway.
Okay. Yeah.
You know. Okay, the first thing to do, or the first thing that I did anyway, was go to a website called desertdomes.com. There's a comprehensive dome calculator there. Anywhere you look on the internet, you're going to see the references to desert domes when they talk about geodesic domes. That's Timmy the dog there. Anyway, and there I decided what size dome I'd like. I entered the diameter, which in this case is going to be 2.3 meters in diameter. It's the radius, so we're going about 4.6 meters in diameter. So I'll just turn around and show you the calculations. So in this case, Desert Domes recommended that I make for a 3 frequency dome. The first length to be 893mm, 966mm, 986mm, and these are the quantities: 80, 55 and 30. Okay, just to be completely accurate, I went back to the Desert Domes website and started my calculations from zero. So in this case, I picked a radius of 2.3 meters, as you can see, 4.6 meter diameter, and it's a 3 frequency dome, so we have 3 strut lengths: strut A, B and C. For the size of the dome that I want to build, strut A is equal to 801 millimeters, strut B 928 millimeters, and strut C 948 millimeters. It's recommended that you add 1.5 inches to that length to allow for the 10mm hole to be drilled on either end. So 1.5 inches in millimeters is 38 millimeters. Add that to each additional length here. Strut A then becomes 839 millimeters, strut B 966 millimeters, and strut C 986 millimeters. It also gives you the quantities required for each strut. So I need 30 of strut length A, 55 of strut length B, and 80 of strut length C. By multiplying out the quantities, I can get the linear meters required. So 839 multiplied by 30 is 25.17 meters. 966 multiplied by 55 is 53.13 meters, and 986 multiplied by 80 is 98.9 meters. These are all rounded up to the nearest whole number, and then I add those together and I get 157.2 linear meters. Now the 3/4 inch, or in terms of millimeters again, I'm just going to keep referring to things in millimeters to make it easy. 3/4 inch in millimeters is 19 mil. So 19 millimeter diameter, 2.5 millimeter thick wall. They are sold in 6 meter lengths. So 6 divided by, 157.2 meters, which is the sum total here, divided by 6, which is the length of the bars, equals 26.2 lengths of 19 mil, 2.5 millimeter wall galvanized pipe. Just to be sure that I'm not cut short, I ordered 28 lengths. It's a little bit more expensive, but in order to have all the metal here on time and without being left short, I ordered some extra. I ordered 46 2.5-inch nuts, bolts with 2 washers. Now I ordered locking nuts for those bolts just to make sure that I don't have to constantly go tightening, and a washer for the inside and the outside just to give a good firm clamp on all the connections. 46 is the total number of connections between 4, 5 and 6 where they join together. You'll have 4 pieces joining together, 5 pieces joining together, and 6 pieces joining together. Alright, so we've been making the struts now for about a day, maybe 5 to 7 hours. I've cut all A, all B, and the last one's now the longest ones at 986 millimeters is bar C. So I've set up this jig, a vise to clamp and hold the bar because it's 6 meters long, it's a bit wavy, a support prior to the cut, and then just marking out 986. I prefer to do this each time just to make sure it's accurate. I've been using an angle grinder, 4-inch angle grinder. So far I've gone through about 6 discs, and I have about another 40 or 50 so to cut. So I'm just going to illustrate how I cut them. As I say, support clamped on my little pallet setup and a vise. Just want to cut the last 2 bars for the entire dome. Again, these are the longest ones. They are 986 millimeters. Like I say, clamped at 0, measure to 986, and make your mark. Get your angle grinder. I'm in the shed and I've cut all the bars now to length and marked them A, B and C, and I've set up a few options here to try and flatten the bar. I'm trying to make this so that if you're at home and you don't have any fancy press like I don't, you don't want to go investing in it, there must be some way of cheaply and efficiently flattening these bars. I haven't figured it out just yet. What I'm looking at here, I'll show you now. I just turn the camera around. I made up this little gas bottle stove and I filled it with charcoal and tried to heat and melt the bar. There's my own little workshop stove. And let me show you here what happened. These are some of the hand flattened bars that I've made. It's hard to get it accurate. I've more or less flattened them down, but to be honest, after I made this jig here for resting and flattening it on this plate here, and I used this heavy sledgehammer, this smaller, lighter sledgehammer, and then finally the standard hammer. And to be perfectly honest, I've had enough. I can't do it by flattening it like that. So I'm going to bring it to some engineering companies and see if they can help me out. Okay, so we had a bit of luck today. I found someone to flatten the bars on both ends. I flattened them all about 2 inches in from the edge to give me a good old work surface. And I'll just bring you out and show you some of them there. Yeah. These are all of the bars flattened on both ends. And here's a little jig I made. Right. I cut a little slot out of the middle just to lie the bar in. Made up the stop block. Try and show you that there. It's 1.5 inches wide, when the bar is flattened. The inch bar comes out about 1.5 inches, and 3/4 inches in from the edge, the centre of the drill bit. It's just bolted on a pillar drill. I was going to use this one, but it's not that accurate, so I'm going to use this one instead. I'm just going to apply a little bit of oil to preserve the drill bit. Just slowly drill through. Don't put too much pressure on, otherwise the bit tends to bite into the metal and pull it up off the jig. Don't wipe that off with your hand, just use the brush or a piece of paper. That's going to complete both ends. Okay, just a quick update before I go down and show you the dome. In the last couple of hours, I rounded off all the edges, got rid of all the burr and all the sharp bits around the ends of the poles. They've been flattened, pressed and drilled as illustrated up till now. And myself and a colleague here, Michael McShane, gave me a hand to put it up. And we have the first round up now, so that the round shape is there. And so let's go down and I'll give you a quick look. Okay, and here's the measurement. 40 feet and 5 inches around the halfway point of the dome. You can see the tape there running right away around the centre. That gives us our circumference middle ways up. Now obviously, being a 5/8 dome, it's smaller on the bottom and even smaller again on the top. But as a centre circumference for the widest point, about 40 feet and 5 inches.
Back here. Okay, let's move this way.
So Dave, that was great. You have lovely plants here now in the tunnel. Just as a conclusion, would you tell us your website as well, because you sell them as well? I want you to get a bit of business as well.
We manufacture and sell these domes, all handmade to order. So this particular dome is a 15-foot diameter, but we can accommodate anything up to 40 and above feet.
And you'll send them across?
Absolutely anywhere, the ends of the earth.
Brilliant.
So we hope you found the video instructions clear, easy to follow. As I say, we took you through the step from calculating the dome to cutting the steel struts to flattening the ends. We showed you how to construct the dome, and then the methods we used to cover it with the shrink wrap plastic. Yeah. So it's not the ultimate solution to shrink wrap, but it's a good cost-effective solution, and as you can see.
And you use actually
works,
what kind of there's this hard plastic you're using?
Yeah, but it's possible to get tailored PVC covers. There's manufacturers that have experience in making dome covers. You can Google them on internet. There's some good ones. Bond Fabrication in the UK, and they'll manufacture a custom cover to fit your dome. You know, so that's no problem if you're interested in doing that. So check out the website. It's geodesicireland.com, and if you have any queries, send me an email and we'd be happy to help.